Hello, everyone, and welcome to the Exchange Biomechanics Challenge. So my name is Maria. I'm the main organizer of the Exchange Biomechanics Challenge. And I think some of you might know me from at least a previous version of the Exchange Biomechanics webinar that we did last year. So if you were here last year and you already know me, please write in the chat, in the questions, so I also know that all of you can find the questions. It's very important for this webinar that you'll find the questions, so you can also interact with us throughout the webinar, and we'll have specific points in the webinar to answer to your questions. So feel free to write down, yes, I was here last year. So put that down, and I can see, and I can recognize you. This event, for who is new here, this event aims to students to create awareness about a problem in the healthcare world. So it provides you the opportunity to work with new technologies such as XNS motion capture and to facilitate connections between you and the rest of the participants around the world. And that are working also this challenge, you can also have contact with the experts in the field in the later stage on the final presentation. So even if you are not in the final selected for the finals, you can still attend and you can still interact with all the other students around the world and the experts that you will have there. So I think the number of people joining the webinar stabilized a bit now. We are a lot of people here today, so I want to get started. So this is our agenda for today. We will start with a general overview of the challenge. I will go over all the details, what is expected, what are the deadlines, what you need to deliver. And then I will give the word to Maike. Maike will introduce Movella and XNS products. Maike is an application software engineer in the solutions team at Movella, and she's working already with us for 13 years. So she has a lot to tell you. She has a lot of knowledge about us. Then we have our guest speaker, Juan. He's a PhD student in the University of Twente, and we'll go in depth about the topic of the case study, which I'm not going to reveal already now, but you'll get to know later today in this webinar. And then finally, Carmen will announce the case study and the specifics of what you will be working the next 2 weeks. Carmen is a technical application specialist and a team leader of the solutions team at Movella. Carmen, as a background, is a technical physician, so she also has a lot of clinical background and experience at the hospital and healthcare. So last year, for who was here, you must remember, for the new people, we had a case study that was provided by the physiotherapy clinic ProAF, a physiotherapy clinic close by us here in Enschede in the Netherlands. And in this case study, the students and the participants needed to compute power out of kinematics only provided by XNS recordings of 4 different exercises. We had 22 teams participating out of 41 different countries, and we covered all the continents almost of the world. So this year, the challenge was provided by the University of Twente, by the Department of Biomechanical Signals and Systems. This group is working on combining advanced ambulatory sensor technology with a broad knowledge of the human body to improve prevention, diagnose, and treatment of sensory and motor dysfunctions. They focus not only on the clinical setting, but also on the setting at home to study what are the differences. So we are working with a Professor Richard van Bazel that works on the Radboud University as well as the University of Twente, and his research is focusing on understanding how a group of neurons can result on a certain behavior. And he also has a large research in the topic of the case study that we'll have in a bit. Then we have Emily Claver. She's helping us also in this case study. She's a technical physician, and she's also doing a PhD in the department of the Professor Richard van Bazel. She is specialized in deep brain stimulation for movement disorders, and she was highly involved in the process of vibrating socks for people with neurological diseases. And then after, Juan is graduated in electrical engineering in Colombia, and is currently doing his PhD in also this department, working on a project related with neurological diseases. So, who do we have here today? Today, we have about 145 teams participating in the challenge, and about from 39 different countries. And again, as last year, we had most participants from Colombia. So congratulations, Colombia. You are here in big force. And then as a support, this year we had Canada in second place with about 20 participants. And then we have the Netherlands in the third place with 19 participants joining us. So the timeline for this webinar. As you know, we started the registration on the 1st of March, and then we closed the registrations yesterday on the 20th of April. Today, we are here to announce the case study to let you know what you are going to work on the next 2 weeks. And next week, you will have the chance to ask your questions. Any technical question, any question that you have about the case study, about the recordings or the software that you are going to use, you can ask on that session. But you also be trained on how the best way to use the software. Maybe some tips and tricks to figure out which data to use or how to interpret the data that comes out of Xsense products. So be there. There will be 2 sessions, one at 10 a.m. in Amsterdam time and one at 10 a.m. at LA time. So you can choose which time fits you the best. On the 6th of May is the date that you need to point on your calendar to send your results to our email. biomechanics.challenge@movella.com. So don't be late, because unfortunately we can't accept reports that are sent late. So be on time, and you need to send everything that you have done so far. And then on the 19th of May, we will have the finals. So only 10 participants, 10 teams will be selected to go to the finals. There we will have our jury committee, which are experts in the field. It's a very large, different people that work in the same area, but with different skills that will be there, and you can interact with them. You can ask them questions. There will also be space for networking, not only for the presentations. So this is what you'll get today at 6 p.m. in the Netherlands time. Everyone will receive in their email box a case study description. Is a document that you should read first. Make sure that you read it carefully. There is a description of the whole case study, as well as what you need to deliver, how the report needs to be structured, where are the links for the webinars, to register for the Q&A, etc. So make sure that you read it first, and then you can see how you can work from there on. You also get, together with the case study kit, a lot of recordings from 3 different patients. You need to use these recordings to analyze your data to get your results, but I'll let you figure that out. And then you also have an Mvn license that is written in the case study manual. So you have all the steps to download the software and to activate the license. And this license is only active until the 6th of May. So after that, you won't be able anymore to use the whole program. But during these 2 weeks, you have full access to all the features that the Mvn software provides you. So then on the 6th of July, you'll need to deliver the report, which is a 4-page report, plus any additional files that you might have that might be important for you to enrich your report. This is, for example, any code that is relevant for you to add. This could be other things that you come out of the box, but make sure that is not really more text or just an extension of your report. It needs to be really an extra to it that is really relevant to add. Okay, and with this, let me just go through the chat to see who is here. We have people that was the first time. There is also, some people that was here last year, and more people that come here again. Really nice to have you all. Right, very good. So I want to start by giving the word now to Maaike. She'll go into more detail into Movella and Xsense products, so I will let you with her.
Okay, thank you, Maria. I will tell you a little bit about our company, about the hardware and the software that goes with it, a little bit in depth about some applications. And I will shortly introduce the reports to you. So we'll start with the company. We started as a XSense company in 2000. We come from 3D orientational tracking. From there, we also went into the body motion capture. After a couple of years, we were bought by M-Cube, and together we will go forth. We started, of course, in Enschede in the Netherlands, and then we opened an office in LA. And after that, China and India were also added to the list. And at a certain point, also Kinect was added to the list. And with the three companies, so M-Cube is a MEMS company, so they build really small sensors. Kinect is an athlete management system. They have a really nice system to consolidate different data sources and present it in a really nice way. So with the three of us, we can make really nice products. And to do that, decided to go forward under one name. So from now on, we are Movella. Now, what does it mean for the XSense brand name? Now, not that much. For now, we just add the by Movella label. And of course, our XSense templates are replaced by Movella templates. Now, only in the Enschede office, we already have more than 100 people running around now. So we are getting a really big, we're starting to get really, really big. So next part, the hardware. So this will be the hardware which is used to measure the data you will get. First, I will tell you a little bit about the motion capture, full body motion capture suits. They have 17 inertial sensors and they can be used anywhere. So you don't need a studio, you don't need fixed cameras in fixed places. So you can use them outside or inside and at your home, everywhere. But what is a inertial sensor? So they are also called IMU sensors, and they combine the data of a gyroscope, of a magnetic field sensor, and of an acceleration sensor. And together we can measure movement and orientation, and we use the magnetic field to stabilize our heading. All this data is put into a really big fusion engine, and the fusion engine enables us to combine the data of the different sensors, but also from one sensor at a time, and make it a perfect product, which is almost magnetic immune. Now we have two bodysuits. We'll start with the link system. The link system is our wired system. So it's wired to a body pack on the body. The body pack is connected through Wi-Fi to the software, and it has an output rate of 240 Hertz. So it's a really nice suit. It has high quality data. The only thing is you need to put on the whole suit to let it to work in the best way. Next to this, we have the Windows suit. The Windows suit is completely wireless. So it talks to a Windows station, a radio-based protocol Windows station. You need one station per suit. The output rate of this one is a little bit less, at 60 Hertz, but you use straps instead of a complete suit. So that gives this one a bit of an advantage in, for example, home uses. Then we also have our third system I want to show you today. We have a lot more systems, of course, a lot of more sensors, but this the dot sensor is a bit of a new sensor for us. It's a Bluetooth-based sensor. It talks to tablets and phones. It's able to do on-sensor recording, and it would be ideal for home use. So we are still trying it out and getting the best out of it. The first application already built with it. I will tell you a little bit about our software. Now, the base of our software is the Mvn Engine. Our Mvn Engine combines all the raw sensor data from all the different sensing elements, but also from the different sensors. So it's the gyroscope data, accelerometer data, the magnetic field data, but we can also add positioning aiding like GPS, GNSS, and barometer data. And together, we get really nice results. So also, if your live recording doesn't look perfectly fine, after HD processing, it can be fixed completely and have the best quality data. It's also able to detect contact points, and not only from feet, but also from hands and everything. If you sit down, it will also be able to detect that you're sitting down. And the magnetic immunity is also mostly caused by the sensor fusion engine. Now, a bit about the MVN product you will use, the Mvn Analyze. It has real nice features like the real-time visualization. So while you're recording data, you can directly see what's happening on the screen. The reprocessing solves problems with, for example, buffer data. So when you are out of reach of the Wi-Fi system or the Windows station, we buffer some data on the systems, and the MVN Studio software is able to get all the data back in the original samples. This improves the overall quality a lot. We have 3D kinematic output like joint angles, acceleration data, and it's all shown in graphs. And of course, this is all validated data. And we also have the option to synchronize with other systems. And there's a lot of ways to export our data. Now, then I will show you a little bit about our applications. I will start with a movie. Yeah, it starts. Okay, so I will focus only on the human motion measurement side of it, so the 3D kinematic stuff. This is a nice example of where our system can be used. It can be used everywhere, so we can just take it to a patient, to their home, and measure them in their own situation, in their own environment. So they don't have to go to a hospital or to a clinic or to a physician's workout place. We can just measure them at home. And during those measurements, we can also show them their data back. So we can show them what we see and what could be better. This system can be used everywhere, so also around big machines. So it's ideal for ergonomic problems. So see how ergonomically okay your workstation is. There are already applications that use our system and that can give you feedback about it. We can also measure what happens with your body while certain situations, or see what happens when you climb a stair. And Mo is also really good at climbing stairs, of course. As you can see in this part of the movie is that you have direct feedback also on joint angles and everything. And our system is robust enough to be put onto a football player. And also then our acceleration sensors are able to track his performance. So in short, lab quality motion capture everywhere. Now then I will show you a small application of the dot. The dot can also be used in an ergonomical situation for ergonomical applications. This tool is to identify the physical loads. You can plug and play with the dot in 5 minutes. So you can put it on, you can turn them on, and your phone will find them really, really fast. And you can track your employees' physical risks at every different workstation. So yeah, you don't need the cameras or anything around it. Then, last but not least, I will tell you a little bit about our reports. Our system can measure a lot of data. So for example, if you are a physician and you have a lot of patients and you want to analyze certain parts of their data, you can record all the data and you can analyze it. But analyzing can be really time consuming. So we created reports to do it automatically. Now, our reports, for example, this Gait report, analyzes people walking, and we can show a lot of different type of data. So number of steps, distance walked, but also the distance every step made, and then for your left leg separately from your right leg, and we can compare the two. So you can see if your left leg is reacting in the same way as your right leg, and see if your movements are still symmetrical. And of course, we can also show that in really nice joint angle graphs. And there's a lot of other data. It's on the slide. We can show all of it. But the reports are meant to be a really nice overview of the most important parameters and the most important parts of the data. Okay, this was my presentation. So there's room for questions. I hope you put your questions. There are no questions? Okay, that saves some time here. If you have questions about this, there will be a seminar about this, the software itself. So please let us know, then we can answer the questions during that seminar. Then I will give the word back to Maria.
Okay, we do have one question here. So this question is, can we estimate the muscle forces while moving? That's a very good question. Just only with Xsense, you are not able to do that. We just measure kinematics. Though there is some softwares now that you can import our kinematics, such as, for example, Anybody, and they can compute ground reaction forces and muscle activity with just our information. But our sensors itself and our software does not allow to compute muscle forces. So I hope I answered your question. And if you have more questions, I will, well, there's a lot of questions coming. I can't answer to everything now, but I will make sure that we answer at the end. One more question only that I'll answer now is that, is it possible to use this software to also analyze this data from Vicon? No, that's not possible. So our software only analyzes data from Xsense, not from other softwares. We can integrate, for example, EMG data with our software, so you can have that data immediately in our software, but you can't analyze data from other motion capture softwares into our own software. How does the output data look like? Is it raw IMU data or already reprocessed data? That's a really good question. So we have both. We have the raw IMU data that you can get from the sensors itself, but you also have the data that is processed, so the joint angle, segment position, segment acceleration, etc. And last question, now is really last question. How about the accuracy compared with lab setting mockup? That's a very good question also. So the accuracy really depends on what type of accuracy you are referring to. So if we are referring to position data in space, we have an accuracy of about 1% of the travel distance, only with Xsense. Now we have other integrated systems that can reduce this, can improve this accuracy, but only with Xsense is about 1% of the travel distance. And of joint angles is really more or less the same. We have accuracies of about 3 degrees, which then if you compare between other motion capture solutions, they also differ with each other. So it's a bit hard to say. So we are comparable to other motion capture solutions in terms of the joint angles. So I hope that I answered the questions. There's a few questions coming. I will leave them for later in the presentation, but they won't be forgotten. So no worries about that. To continue, it's the time to reveal, maybe some of you already guessed, but it's the time to reveal what is the case study about? What is the main theme of this case study for this year? So the main theme for this case study is Parkinson's disease. So the data that you will receive is about Parkinson's patients. We recorded those patients together with the University of Twente. We will explain a bit more later on, and we have one to explain you exactly what is Parkinson's and what this disease entails. But to test a bit your study and what you know about Parkinson's beforehand, we are going to do a small quiz for you. So get ready, get attentive. You have 45 seconds per question for you to give me an answer. So you need to write your answer in these questions. I see that most of you have found the questions. So just give your answer there and we'll keep up to check them. So here we go. What is the most common symptom experienced with Parkinson's disease? A, tremor or shaking. B, cognitive changes. C, fatigue. D, impaired posture and balance. E, muscle tension and rigid muscles. So 20 seconds. $15 seconds, almost there. 10. We have 5, 4, 3, 2, 1. So most of you answered tremors or shaking. That's indeed a very common symptom that we see and we relate very much with Parkinson patients. But the truth is that fatigue is the symptom that is most common experienced by patients. So about 71% of the people that were asked, they experience fatigue, and 69% experience tremor and shaking, and about 60% experience impaired posture and balance. Good one. So let's try the next one. Second question. How many people living with Parkinson's disease also have other health conditions? A, 30%, B, 57%, C, 63%, D, 80%, E, 91%. Wait. I just gave you the answer. My counter is not working, so you guys need to be fast now because I'll be counting much faster. So I won't count this one. Everyone said, E, woo! You all win this one. So it's true. A staggering of 91% of the people living with Parkinson's disease also have other healthy conditions. And most of them are arthritis, for example, 35%, depression, 33%, hypertension, or also high cholesterol, all about 30%. So next question, here we go. Third question. How many people with Parkinson's disease feel their condition has a significant negative impact on their household finances? A, 7%, B, 20%, C, 35%, D, 50%, and E, 86%. Okay, 10 seconds to go. 5, 4, 3, 2, 1. So a lot of you wrote between 50% or 86%. I must say that was not really correct. So it's 20% of people living with Parkinson's disease have a negative impact on their finances. 10% said that they use financial support program from the government, for example, and 7% avoid or stop using medicine due to costs. So it's a quite relevant and also significant reason to not continue, to have a negative impact on their finances. Something to keep in mind. So next question, we have 3 to go. So people with Parkinson's said this is the most challenging symptom to live with. Which one is it? Cognitive changes, fatigue, changes in difficulty walking, pain, or trouble sleeping? Ten seconds to go. And in 5, 4, 3, 2, 1. So most of you decided to go for changes in difficulty walking. That's also true, but not really the correct answer. So the correct answer is fatigue. 50% of people experience fatigue, and it is the most challenging symptom to live with because the fatigue interferes with making all the plans and making all their life decisions. So they say that they also lose a lot of independence because of that. And 10% of them said difficult to cognition, difficult to live because it's also it's difficult to communicate with others if they also have troubles in cognition. So next question. Besides prescription drugs, what is the most common way people cope with Parkinson's disease? Humor, faith, friends and family, meditation, or staying active exercise? 20 seconds. 15 seconds. One to last question. And in 5, 4, 3, 2, 1. So the most answered question was staying active or exercise. And it's correct, but no, I'm just kidding. It's the correct answer. It's true. Staying active and doing exercise accounts for 66% of the people that experience Parkinson's disease and that try to cope better with it. Also, having some humor, some laugh is also about 50% of people answer that. And also having some faith and spirituality also helps for some people. Okay, the last question. Are you all ready? So here we go. Last question to test your knowledge about Parkinson's. What is the most common exercise for people with Parkinson's disease to use to stay active? Is this biking, stretching, walking, gait and balance training, or yoga? Twenty seconds to go. And almost there. Okay, 5 seconds. 3, 2, 1. So the answer that you respond mostly was between walking, gait, and balance exercises. That's correct. It's gait is the most common used activity with the Parkinson's people. And just, oh, I forgot to put the correct answer. So, so the others such as yoga also helps a bit for our meditation. But most of them definitely wrote walking. Okay, so it's enough. I think all of you had done quite well. But I hope that now in this challenge you get to know more about Parkinson's. And for that, I want to give the word to Juan that he can explain you much more about it.
So I'll explain a bit more about what's Parkinson's disease. I wanted to, show here like some part of the epidemiology. Parkinson's disease is the fastest growing brain disease in the world and also one of the nastiest one can have. Recently, researchers started calling it the Parkinson Pandemic, and it is fueled by aging populations, increasing longevity, declining smoking rates, and by the byproducts of industrialization such as pollution and fertilizers. Also, the incidence of Parkinson's disease increases with age, as already mentioned, and rises sharply at around age 65. Parkinson's disease is caused by the deterioration and destruction of nerve cells in an area of the brain called the substantia nigra. These neurons produce a neurotransmitter called dopamine that is also used to communicate with other neurons in the brain. Dopamine is also involved in our reward system. It helps us try, focus, and find things interesting. It also plays a critical role in a number of bodily functions and such as movement and coordination. Here we have an image of fMRI of a normal person. And then we have fMRI of Parkinson's, a person with Parkinson's disease. And we can see that the substantia nigra, the activity of the substantia nigra is less, the substantia nigra is less active in the person with Parkinson's disease. The slowness of movement, the trembling of the arms, which occurs typically when being at rest, the symmetry of the disease, which we still do not understand well, and even something as simple as controlling your saliva and swallowing becomes very difficult, as well as putting on your jacket becomes incredibly complicated and slow. People with Parkinson's say that the problem with movements is just the tip of the iceberg. Parkinson is an incredibly complicated and disabling disease, which also causes problems with thinking, mood, urine, stool incontinence, sleeping, and also sexuality. Here we have an example of what tremor is. You can see that this is resting tremor, and you can imagine it could be very disabling in daily life activities.
A patient with Parkinson's.
This is another symptom that is also very disabling. It's called freezing of gait. Freezing of gait is when people want to walk, have the desire to walk, but they are either glued to the floor. That's how they say it, they express it. Or you can also see it as trembling of the feet, like a fascination in school. This symptom is also very disabling because it can cause fallings and like what also comes with fallings, including death. But also it can leave you to fear of falling. That is also very disabling because you stop doing your daily activities as you used to. Let's talk about a bit about medication. Because dopamine is the neurotransmitter that is not, the brain is not producing there as much as before. The medicine used by people with Parkinson's disease is levodopa, that is used to help symptoms. However, this medicine has side effects. You can see in this graph the daily on and off fluctuations of the drug levodopa, and you can see that in the peaks you have something called dyskinesias or dyskinetic movements. This is a side effect. It's not part of the disease, but it's a side effect that also affects people with Parkinson's disease. What I want to mention on this is that because of these fluctuations, the monitoring of the symptoms are very important to be able to have, to control the doses and to better treat the people with Parkinson's and ultimately help them.
So
this is a video of a dyskinesia that, as you can imagine, could be also very impairing. It's related with random movement, uncontrolled random movement, as you can see in the video. The MDS-UPDRS is the standardized scale for us to assess Parkinson's in the stages of the disease. That is not just movement, but we also check for non-movement symptoms. For the movement part, we have 4 pillars. That is bradykinesia, that is slowness of movement, rigidity, tremor, and gait and balance. I want to show you a bit of how is the test. You can see it now.
Good. Let's try the other hand, as big as you can, and go here a little bit. But I have to do the activation maneuver because these medications are working so well. Very good. Perfect. Good. One more time. Excellent. So as you can see, Larry was able to catch his.
And finally, I want to show you a small video that is with Michael J. Fox from Back to the Future. He has Parkinson's and he's very active in the community and works proactively just supporting financially, and also to show people what is Parkinson's and how we cope with it and how we can improve people's lives.
It's disease. I soon learned that each patient has their own version of Parkinson's, their own story to tell.
I was diagnosed in 2006. It was 2 weeks after my 39th birthday. That just came across me like, where did this come from? Why me?
I had noticed a few years prior that I wasn't smelling things as clearly, and I started off just kind of noticing a kind of a kink in my arm before I could just stop it. But then it came to a point where the thing that stops it, it wasn't there anymore.
I was writing thank you notes to people for my 50th birthday party, and I would start the note, the letters would get smaller and smaller, and sooner or later the hand wouldn't move. So I said, there's definitely something going on here.
About 2 years ago, December, I just had problems running. Like, my right leg just didn't keep up with the left leg. And I sort of blew it off. And then my husband saw me running, and he said, "What's wrong with you?" And like I had a stroke.
It was like you had a stroke, or you did have a stroke?
No, I didn't. We were on vacation, so when we got back, I finally went to the doctor.
I had a really strong hand tremor, and I went to Portland, and I kind of hid it for a while, and finally I was diagnosed. And I remember when you came out and told the world that you had Parkinson's, I just thought it was just a disease that made you shake. That's the only thing I knew about it.
So what was the reaction of your family?
Well,
All right, so I replaced Juan there. So now's the time for you all to get to know a little bit more about what this all actually means for you guys in the challenge. So I'm going to release the case study here. We're going to go a little bit more into, why Parkinson's and why XSense. And we'll also go over the stuff that you guys have to compute. So we partnered up with the University of Twente, where Juan is doing his PhD on the Parkinson's subject. They have this really nice e-health house where they measure Parkinson's patients in a nice home environment simulation. Currently, the assessment of the state of the disease is being done at the hospital by a neurologist. However, the symptoms that are being assessed often present themselves differently at the neurologist examination lab than at the patient's home life. Additionally, a lot of patients tend to forget to tell about some of their symptoms, or they downscale the severity of them. So this e-health house will simulate the patient's home environment, and they are measured with the XSense sensors all day. So in the morning, they will be analyzed without medication. We call this the off period. They will do their daily tasks like getting out of bed, making a breakfast, doing some dishes, going for a walk, etc. And then at lunch, they will have their medication. So in the afternoon, they will be in the on period. They will do the same tasks again. So getting out of bed and making breakfast and everything. So this way we have a really nice comparison about how people act on medication and how they do off medication. So why do we want to measure patients with Parkinson with XSense? Well, firstly, our sensors allow us to capture objective data sets. So instead of the neurologist just looking and semi-subjectively assessing the patient, we can now help him with accurate numbers and figures. Additionally, the use of XSense will allow for remote measuring and monitoring. So XSense can be used anywhere, anytime, and you can imagine patients at some point taking the sensors home, being measured for longer times of periods in the comfort of their own homes. And finally, because we can measure them for longer periods of time, we can also detect when there is not enough or maybe too much medication, the levodopa. So you can imagine that at some point, we are working towards some sort of a closed loop circulation where the dopamine levels will be automated and regulated on a personalized basis by detecting the symptoms through our XN system. All right, so what does it look like to measure a patient with XNs? Here you can see the patient actually having a tremor on his left hand, but when he focuses on doing a task, the tremor stops. So that's quite interesting. The tremor only occurs when the patient is at rest. Additionally to the tremors, this patient has some other measurable symptoms like having trouble standing on one leg, but also having problems initiating his walk, turning around, and all sorts of normal tasks for healthy people. He is now turning around. That's quite rigid and static. And he starts to walk. All right, so what does this mean for the calculations? What will you guys actually calculate during this challenge? First of all, of course, we're going to be detecting tremors. So you guys are going to focus on the tremors. You're going to detect when the episodes are happening. And then you're going to focus on the characteristics of those tremors that you can find in our kinematic data. You can think of anything that is characteristic for those tremors. Be creative in the way you calculate, and then finally focus on the differences between the on and off period. We will provide you with data. There will be 3 patients who are both measured in the on and the off period, so with and without medication. And we hope that you can find some differences there. Secondly, you guys be focusing on balance. So you're going to analyze the balance. Are patients losing their balance? Can you detect when a patient is out of balance? And what does that look like? So what kind of characteristics are there if someone is out of balance? And can you detect differences between on and off periods? And finally, you guys will be assessing gait. So you're going to examine the walking pattern of the Parkinson's patients. As Micah mentioned before, we have some reports. We already created some for you guys on the Parkinson's patients. So they'll be included in the kit, and you can really examine the gait specific parameters there. Then there's also the freezing of gait. So we're hoping you guys can detect them, find some periods there, and really see or comment on what is the difference between freezing of gait or just not walking. And finally, of course, is there a difference between on and off periods? And then finally, this is optional. If you still have some time left, you did all your analysis, you're quite happy with what you guys found, then there are still some other options that you can assess for some additional credits, of course. So we have posture analysis. How does this differ from healthy people? And what are the differences between on and off periods? And then any other additional parameters that could possibly contribute to the detection, the monitoring, or the future of Parkinson's. One tip, look at the UPDRS scale. You can really find a lot on Parkinson's there. And finally, we would like to challenge you guys to design a home monitoring system that uses XNs at the patient's home environment for longer periods of time. All right, that's it. Then, are there any questions?
So, there are some questions here already from previously. Maybe while you insert the questions in the chat, I can ask some questions here. So, how did you calibrate that? How do you do the calibration that requires stillness in a patient with tremor?
That's a good question, and that's actually really hard because if they're standing still, they are going to have tremors. However, if they kind of focus on something, you can have them stand still because it's a resting tremor. So if they become more active, it might diminish the tremor as much as possible. And for the rest, it just gets as good as it gets.
There's also tips, you can, for example, hold the hands of the patient. You can also try to hold the patient in a upright position as much as you can. And then you will have some default joint angles, which is a challenge to try to work around that because there's a lot of other parameters that you can look to analyze Parkinson's, only the right fully posture. So this was one. Do we have more? We will do all the required tasks or just focus on some selected tasks by us?
Well, we actually have 3 quite big sets of data for the patients. We already kind of described, which is on, which is off, what kind of tasks are in there. But it is really up to you to go through the data and find the certain points that are interesting.
Good. So next question: what stage of Parkinson's is this the case? What stage of Parkinson's?
Yeah, maybe you guys can determine that, but they're definitely at a progressed state. It's not. You can definitely see that they are Parkinson's patients.
Okay. So more questions. During the calibration step, we let the subjects walk back and forth 1 time. A subject with Parkinson's may also shake during the normal walking while the calibration. If we include that shaking drifts the calibration, how the system determines the normality afterwards, or we make the calibration again and until it gets perfect walk while calibration.
Well, we actually have in our newer version of Mvn Analyze, it's not necessary anymore to walk. So you can make any movement or walk around, doesn't matter what you do, it will calibrate. So it also doesn't matter if the patient has a tremor or it will not be causing any drift.
Should we pre-process the data, like filtering, removing noise, etc.?
Well, I mean, we wouldn't be Xsense if we wouldn't have already done that. So you guys get really clean data. It's already HD reprocessed and everything. However, if you'd like to go, for instance, in the frequency spectrum, yeah, then you'll have to do some signal analysis there.
Does it mean that we are not expected to complete all 3 tasks?
You are expected to complete all 3 tasks, yes. And then if you still have time left, go to the other ones.
Are we free to determine which outcomes we are going to use, for instance, in Gait?
Yes, you are completely free. So find the ones that are interesting, elaborate on why they are interesting, and then point them out to us.
Sorry, there's way too many questions coming. I'm trying to keep up. Yeah, so there's some more technical questions about the Mvn software. So do the software support real-time outputting the data of the pose while moving? So I can answer. Yes, it allows. You can stream directly the movement of someone into other platforms. We have a TCP and UDP protocols that you can stream into MATLAB or even into gaming platforms such as Unreal or Unity, exactly. You do have the scripts to stream into MATLAB available on our downloads, and also a tutorial video about it if you would like to work on that. To use the model with the Xsense sensors, it is required to scale the model, or the sensor location adjusts, or the sensors adjust to the body?
Well, it is required to put in the height of the body and the shoe length. And by inputting that, we have a very nice biomechanical model behind it that will estimate the rest of the joint lengths or segment lengths. However, you're also free to measure them and input them. And of course, then the avatar will be automatically scaled.
So what happens in HD reprocessing? Does a program learn from the whole data set captured and thereby improves accuracy?
Yeah. HD reprocessing does all that. It's a very fancy way of calculating both the data that has already been and the data that's already coming. That's why we do it afterwards. So we have the whole measurement. We can really take all the data into account and optimize it through fancy algorithms.
All right, one more question. Specifically, Xsense MTW window is sensitive to gravitational forces as well as magnetic forces on Earth. If we put any magnetic material close to the sensor, will it affect the output?
No more. We have magnetic immunity through our fancy algorithms. So we've actually found a way to calculate our way out of magnetic problems.
So this is to take into account that you are using our Mvn software, of course. Yes. Okay, more questions coming. In the optional, what do you mean by designing the system?
That's a good question, actually. You're quite free to design the way you'd like. This can be in the shape of a PowerPoint, this can be a mock-up, or it can be just a textual description of a design.
Okay. Is the tremor only happening on the left hand or other segments as well?
Good question. The data is in the data set, so be free to check it out.
Yeah, so you get the data at 6 today. So wait for it, you have all the things there, and you can analyze, go through it, and that's your task.
The patient in my video was patient number 8.
So, should we have a model that detects these events for new patients, or should we just detect them in the 3 patients?
For now, just detect them in the 3 patients, but keep in mind that this could be a way to, generally use this. So definitely for future patients as well.
Okay. Do we have to share the codes we created as a result of the research, or are just the outputs enough?
The outputs are enough, but it does help your case to upload the scripts and to send them in the appendix of your final thing.
Okay, should we have sorry, I repeated this one. Can we use other sources of data or just have to based on your data set?
Yeah, you are limited to our data sets. You can use your imagination in home design, but the data that we'll send you is purely Xsense data.
Okay, last question. The simulations using Mvn software require always to have information of 17 sensors, or can we use less sensors as the X dot set or the dot sensors only 5?
Good question. That is, I think, a really nice one to answer later on. You have the freedom to use all 17 sensors, but we do challenge you to look at only sensors at 1 point or 2 points and work with that as well to simulate the dot environment.
Okay, so should we, it's not the last question yet, now is the last question. Should we do the task on the team or can do it individually, and how if now I am not belonging to any team? So you can do it individually, that's fine. Might be a bit of a lot of work, unfortunately, but you are free to do it alone. And last year we also had people doing it alone, and it's okay. You can just still do the challenge and send your report in.
Is there any way for people who are alone to email us and maybe we can set them up together as a team? They can work online?
Yes, if you would like if you are alone and if you'd like to connect with people and you don't mind, so I want to emphasize that if you don't mind, so you can share the email, you can send an email to biomechanics.challenge@movella.com, and then I can connect you with different people. But make sure that if you send that email, you are aware that your email will be shared with other participants. Okay. can we use your data set of writing the paper after this challenge? We would like to write publication relating to these selected tasks. Yes, so you can also write a paper. If you have good enough findings and you want to write a paper, that's fine. We also had people last year that did it. Please just say that you were from the Biomechanics Challenge. It's really nice from us to have there. And it's also a great opportunity for us to know what you did. And we really want to keep following you and be in contact with what you have done. So go for it, but just also let us know, because we are happy to hear that you are sharing this challenge to the world. So there is one more question. So who gets the XSense prize if combined?
Yeah, that's a good question. And that's a really hard one as well. You guys will have to figure that out between you guys in the team.
So you will have to sign a price agreement form, which you'll need to specify an address, and you need to be assigned for all the team members, and you agree with all the team members that the system will be sent to that address, and then you will be the ones responsible to share the price between you.
So that's also a good excuse to then finally meet in person.
Can I have the schedule again, please? Well, don't worry. In 1 hour, you'll get that into your mailbox. Everything's super well described. So really don't worry. You'll get that information. You also can go to our website in xsense.com/biomech-challenge 2022.
Also, this presentation is recorded and you'll be able to look it back afterwards.
Should we segment the data into different time windows in order to detect the events?
Yeah, you can.
Who are the judges of the report? That's a very good question. So it's not really yet revealed who are the judges. We have 4 different judges. I can tell that one is a technical physician working in a hospital here in Twente. Then we have someone that is a neurologist that now is working also on research. We also have a professor that is working in a clinic at the same time as at the university. And we have also a PhD student in Amsterdam that is helping us in this case study. So there's a different group. You will all meet them in the finals presentation. They will all give a small introduction. They will all be present so you can get to know them. Who chooses the 10 best teams?
The judges.
Who chooses the 10 best teams? We as XSense, we are not involved on that. They are all from outside of XSense. They don't have any connection with us. And they will be the ones choosing who is going to the finals. We also have a grid, so to make sure that the evaluation is the same for everyone. And then in the finals, they also will evaluate the presentation, and simply the one that gets the highest score is the one that wins. Can we also have the email again? I don't think that's on the website. No, but that will be also on the case study. So if you download the case study, you will also have it. I will just write it down here on the chat so everyone that is here in the chat can see it. Or then I will write it down in a bit so everyone can see the email. So I think we went through all the questions. I want to just emphasize to thank you everyone for being here, but make sure that in this challenge is not about how precise your data is, or how actually accurate and technically correct it is. It's more about how you think, how creative your ideas are, how do you approach this problem. That is more what we'll be looking at. Not only like how technically precise and up to a certain precision your results are. So bring those ideas out, be creative, think about this challenge, and well, I hope that you like it as much as we, and I'm sure that we'll see each other in other parts. So good luck. That's what I have to say.
Thanks, guys.
Thank you. Bye-bye.